Our assignment 3 is about classification and logistic regression. We have 2 exercises, and the first one is about telecommunications operator customer churn. And for that, we have used a data set from Kaggle that you can see here. It's a data set containing different columns describing the customers, and then here at the end we have the churn, so saying if the customer has churned, yes or no. Our dataset, as we can see here, has 7,043 lines and 21 columns. So what we've done here is we've seen, first of all, that for some of the lines, total charges had no value, so we just eliminated them. Then we calculated the base rate, also called the default rate, which is the size of the most common class over the size of the full dataset. And it shows how accurate we would be without using any features. So we found here a base rate of 73.42%. Now we want to build our training set and train the data. So for the columns that we've chosen, we see that some of them, here gender, phone service, and tech support, for example, are non-numerical ones. So they're booleans containing either yes or no that we have replaced by 1 for yes and 0 for no, and then added them again to our data set. Then what we've done is standardized, here only the numerical features, of course, and then again added them to our data set. Then we have done a logistic regression with cross-validation. We have then calculated the accuracy of our train data set and the accuracy of our test data set, being of 80% and nearly 79% respectively. Now we have here the confusion matrix. So we have 3,725 true positives, 780 true negatives, 395 false negatives, and 725 false positives. Then we are showing here the precision and recall score. So what is the precision score? It's the percentage of true positives among all positives that we have estimated. And the recall score is the percentage of true positives among all that are positive in reality. So for our dataset and our estimation, 82.45% of all the customers that we have estimated as churning are actually churning, and 46.15% of the customers that are actually churning we have correctly estimated as churning. Now we can also show in a curve the precision and recall. So we can see it here, which is showing the trade-off between the precision and recall for different thresholds. Now this is exercise 2, which is where we're using a data set about handwritten digits. So it's a 3-dimensional data set that we have transformed into a 2-dimensional data set, where at the end we have 1,797 lines and 64 columns. So now we're splitting here our data set into the train and split sets. Then we're doing again a logistic regression with cross-validation. We calculate the train accuracy, which is of nearly 99%, and the test accuracy of 97%. Then here we have a classification report giving us an overview of, again, the precision and recall scores for the different numbers. Now we have created here a confusion matrix that we can then also visualize here in these graphs. We have once a non-normalized confusion matrix and a normalized confusion matrix that allows us to visualize that our algorithm has a good performance. Thanks for listening.